Right, cool. So I did post the link on Friday for the main cohort. So MVP students, you're probably seeing this for the first time, but anyways. So what you guys will be working on this week for the project week is what's called a cellular automaton simulation. Basically the most well-known simulation attributed to a guy named John Conway, and it's called the Game of Life. We should probably first talk about what a cellular automaton is. So basically, cellular automaton, and pretty much what you see when you look at one of these simulations is you'll just see a large grid with these highlighted dots, which you can kind of think of as like cells or little organisms or whatever. There's many ways to interpret these, however you want to do it. I guess it doesn't really matter. So again, you have this grid, you have these, I'm going to call them cells because it's called cellular automaton. And the idea is that when you start the simulation, each of these cells basically adheres to a set of rules. They all adhere to the same set of rules. And so you basically start off with some starting configuration, like this one, for example. And then when they pretty much the simulation will run and each cell will kind of calculate its next state based on the rules, which have to do with kind of how many cells are around them. So let's not talk about the rules quite yet. We'll get to that in a second. Actually, let me just refresh this instance so we can kind of just see what, like the simulation running in action. So this is just one of the preset kind of configurations. When we start that, let's speed this up a bit. So that you see these cells start moving in these interesting patterns. And again, basically what they're doing is every single one of them is calculating its next state based on some set of rules that, again, we haven't talked about yet. But you can see there's some stuff going on. So what's interesting about this particular simulation, for the simulation to run, for the simulation to run, there's no, once you give it the initial state, right, that initial configuration that we gave it, we don't provide any more input as the simulation runs. So basically this could just run forever now. And each cell will just calculate its next state based on the rules and just keep going, so on and so forth. And so every single, I guess you can call it like every frame that's going on here with every frame of animation is called a generation. When we're talking specifically about cellular automaton. So as these cells are kind of shifting back and forth and changing, you can see this little counter down here, which is again counting all the frames, but in other words, you call it, basically 560 and counting generations have elapsed for these cells, and this is the current state they're in. This is the current state they're in for the 606th generation, for example. Again, I guess you can think of it, that's kind of just like characterization for the fact that maybe we're interpreting these things as cells. But I guess if you want to think about it in a more straightforward fashion, these are just how many frames have elapsed. If you want to think of it in more in terms of the simulation. But, however you want to think about it, that'll make sense to you. So this is basically what you guys will be implementing for this week. Okay, so let's talk a bit about the rules. Do I have those here? Not here. All right, rules. So basically, these are the rules listed out here on this Wikipedia page, and they all kind of have to do with each cell is basically going to look in its immediate neighbors. So basically, the 8 cells that surround it, right? So for example, let's say there's like a cell here, it's going to look at the 8 cells directly around it. So every cell does this, and basically depending on how many other cells are in this cell's direct neighborhood, it will do something accordingly. Pretty much, it'll stay alive, or it'll go out, or in other cases, if there's an empty cell and there are enough alive cells around it, it could come back alive, for example. But let's actually look at the actual rules. So the actual rules say that any live cell with fewer than 2 live neighbors dies, right? So if we have one cell here and there's only one other cell next to it, in the case of these 2 guys, because there's fewer than 2 cells in their immediate vicinity, both of them are going to die, or basically go out, right? Any live cell with 2 or 3 live neighbors lives on. So that's the criteria for that cell to not go out. It needs at least 2. 3 is fine as well. But then on the other hand, if there's more than 3 in the immediate vicinity, then that cell is actually going to go out. And then here's the rule for basically reproduction or repopulation is any dead cell with exactly 3 live neighbors becomes a live cell. So these are the rules. I think when you just kind of parse them in and of themselves, they're pretty simple, right? But what's really cool is based on certain initial configurations, a lot of interesting patterns show up. And so you guys will basically be re-implementing this simulation. And what I really like about this particular project is the fact that I think, like oftentimes with projects that you guys have probably worked on before, maybe you've felt this kind of tension between whether you want to take the project in kind of a creative direction or you want to kind of more focus on the functionality or optimizations, right? I think this project, my point being is that I think certain projects typically kind of lend themselves more to one end or the other. And I think in the case of this particular project, I think you really can take it either way. So if you maybe feel like you're one of those more creative front end type people, I think there certainly are things you can do to kind of make the design more interesting or do more interesting kind of visual things with the cells, et cetera, et cetera. On the other hand, if you are not one of those front end type people and maybe like working on back end and working on the algorithm or performing optimizations and stuff like that, there's certainly also a lot of stuff you can do on that front with this particular project. Things like so like here they have this little zoom out feature. So basically it makes the grid much larger. And you can imagine if you were to zoom your simulation out this much, you're going to have to do a lot of optimizations to keep this running at the same frame rate, because now there's so many more cells. Each one is still performing the same calculations. But we can also see that the simulation is still running at the same frame rate. And personally, from my experience, I know that if you were to try to run this game at this resolution, this takes a lot of optimization. You won't be able to just crank something out kind of naively and get it to work like this. Right? So I really think there is kind of something here for everyone in terms of, whatever you are interested in. I think you can kind of embody it into the spirit of this project. So let's look a bit at um, let's look a bit at the README. Well, I'll post the link at the end. So as far as project weeks are gonna go, this isn't going to be any different from what you guys have experienced with prior project weeks before. So you'll set up a Trello board as your basically weekly to-do list. And then here's a list of MVP features. So of course, you're going to have to figure out how to implement the algorithm itself. A couple of things that you'll want to keep in mind. So you're going to want to be able to toggle on individual cells by clicking, for example. So that's a feature that is part of the MVP requirements. Of course, displaying and rendering the thing. There are a number of ways to do that. You could just throw a bunch of pixels into a bunch of divs. That can work, but it's not performant for sure. For example, then you might want to decide to utilize a canvas or some other sort of rendering option. But at least it needs to be 15 by 15, which granted is not very big. There needs to be buttons to start and stop the animation. There needs to be a button to clear the entire grid so you can basically just start it over. So those are features considered for, well, I guess considered for MVP, but then at the same time, as part of the rubric, we do state that in order to get a 2 on the project, you also need to implement at least 3 of these features. So for example, doing things like creating some sample cell configurations that users can load and run, pretty much just like what we're able to do here in this example here. They have this little drop down. We can go and click some preset configuration and then run that. So this one's called the glider here because as you can see, it's kind of, as the simulation's running, it's kind of gliding along diagonally. These are kind of cool as well. This is called an exploder. And as it runs, it's like oscillating out. And then just kind of by the end, after some set period, you'll note that it pretty much just falls into a set pattern where because each cell is following the same rules, those rules are governing that it just basically enters this equilibrium state. And it's just going to run like this forever, right? So it's not actually changing it. It's just oscillating back and forth at this point. On the other hand, there's this other one called a small exploder, which is a slightly different configuration. It does something kind of similar. It kind of like starts expanding outwards, but then at the end, it hits this configuration, and by the rules, all of these just stay alive, but they don't actually do anything anymore. So even though the generation or the frame counter is going up, we see nothing's actually happening here because all of these cells have entered a steady state. So that's one of the features, doing something like adding a drop-down so that users can load a specific configuration, for example. I think a better way to do this would probably do something like you choose something from the drop-down and then maybe at that point, you could then click somewhere on the grid and that is where the configuration would get dropped in instead of, having to just always with this one, whenever you click on a new configuration, it resets the whole thing, which I kind of wish it wouldn't. But anyways. add an option to create a random cell configuration. So a randomized button that will, I can imagine, would just iterate along every single cell, maybe like flip a coin for each cell, and that'll decide whether that cell is alive or dead. And then you can just run that configuration. You can add additional cell properties, color size. I don't know if we want, I'm thinking we're not going to, yeah, let's say no on whether you want to, on being able to change the rules. So we basically want everyone's to be, we want everyone's simulation to adhere to the same fundamental rules as far as the logic. Allow users to specify the speed, like we're able to do here as well. There's this little slider here that slows up or slows down or speeds up the animation. This one's interesting. Provides functionality to manually step through the simulation one generation at a time. So maybe if you were to enter this mode, you might just have like a button that will say go to the next, calculate the next generation, just display it. And maybe that would happen on each click, for example. Allow users to change the dimension of the grid. We were talking about this a little bit. And I can tell you, I think being able to actually just change the dimension of the grid itself is not difficult, but it's more kind of the implication of what happens when you change the dimension. So if you're able to just keep it within bounds where performance doesn't degrade because of how big the grid is, that would probably be easiest. But then if you allow shifting so that the grid gets big enough where performance does start to degrade, then you maybe need to start thinking about how can I still get the simulation to run at the same frame rate for this larger grid size, for example. Given a specific generation, calculate the configuration of cells at that point, jump to that state by bypassing animation. Okay. So maybe this would be something like, for example, maybe there's a little text box for the counter where maybe the user could instead highlight it and enter a number, say this is going to be the nth generation, right? So leave that in control of the user, and then the simulation would automatically just calculate whatever state all the cells will be in for that generation, and then just render that straight instead of having to go through the animation to get there. Is the idea behind that one. Okay, and then for there are 3 stretch goals here. I think one of which is probably quite a bit easier than the other 2. And that would be the first one: write a blog post or a guide that walks readers through how you actually went about implementing this particular project. I will say the other 2 are, in my opinion, quite ambitious. The second one is basically expanding this to the 3rd dimension using some 3D library like 3JS, for example. So 3D life is a thing, but I also believe it has slightly different rules. Of course, because there's a different number of cells surrounding each one particular cell, for example. Wow, this web page. Not exactly what I'm looking for. Well, if you want to try your hand at implementing 3D game of life, I'll leave the research up to you. The last one might honestly be even more ambitious than 3D. So this is a pretty crazy optimization. This is a pretty crazy algorithm for optimizing game of life. And actually, I think this particular simulation, it probably is using it in the back end for it to run the simulation this smoothly at this resolution. That's what it's probably doing. But the hash life algorithm, what's pretty crazy about this particular algorithm for calculating the game of life is that it achieves exponential speed up the longer the simulation runs, which is pretty crazy. And that's because it's being really smart about caching and memoization. And the way it actually represents the entire grid is not as a multi-dimensional array, but actually as this tree structure called a quad tree. And it's being smart about how those leaves are getting pruned off and stuff. Anyway, I'm not gonna geek out too much here. But yeah, that one is certainly very ambitious, I think. So if you are dying for a 3, you might want to just opt for the first one. Deployment, of course, is also part of the criteria. So I think deployment for this should be pretty simple because you would basically just implement this entire thing on the front end. You could give it a back end if you wanted to, I guess, to where it would do the logic of calculating the current generation, the current state of the generation, but I guess I'm not sure why you would do that. Or I guess I don't really see any benefits to doing it that way. Yeah, not really. So basically, just your app would just be kind of a static front end page, and that should be pretty easy to deploy. But yeah, I think that's pretty much it for the project. Please make sure you're making at least one commit a day. This is so your PM can check in with you in terms of progress. I think there are still going to be PM one-on-ones this week at the end of the day, but I'm not entirely sure. Ask your PMs for that. I'm probably not really the authority on that front. I was totally not on the correct channel in Slack, so I missed everything. Oh boy. But I guess Beej is in here, so he's probably answering all the questions. So that's awesome. Yep. Will there be two different grids, like one the condition into cells that are buttons and others canvas? Like one for the initial conditions. I guess why would you want two separate grids for that? I should probably put the Slack over here. Because why would you need two different grids for that? Oh, or maybe your question has to do with, so like, I don't think, so it wouldn't really make a lot of sense to be able to, okay, so they do allow it here in this particular simulation, like you can click a cell when the simulation is running. But by the rules of the game, unless you're clicking it, for example, like over here, well, okay, so maybe there's some utilization. So right, if you like click it close to another set of cells, that will alter the behavior of the simulation, as we can see. But like, for example, if you wanted to add a new pattern somewhere else on the grid, I mean, that doesn't really work because, I mean, you'd have to click very precisely and rather quickly to get anything to stick. So I think it's totally fine if you just want to enable toggling of cells manually when the game is when the simulation is stopped. Is that kind of what you were getting at? Yeah, okay. Yeah. There is some utility from being able to toggle cells on when it's running, but I think it's also fine if you want to just enable that when the simulation is stopped. But then at that point, I think I would just do it on the same canvas or matrix, whatever you're using. Cool. So a couple of things to think about, at least in terms of how you might want to actually implement the algorithm. So one thing that you might want to take into consideration is what happens when, let's say, for example, you have a couple of cells on the edge, right? So in that case, there are a couple of options you have in terms of how you might want to handle this. You could just have these cells only count for the 5 cells directly around it, or let's say there are 3 cells on the other side. If you were to wrap around the grid, you could also have the cell consider these 3 as being its direct neighbors, so that the grid basically wraps around itself when it comes to each cell, figuring out the configuration of the cells around it. So doing it one way if for example your simulation like went to the edges, the whole thing would kind of peter out. If you opted for option 1 where the cell, if it's at the edge, it just considers the 5 cells around it, or like if the cell is right at the corner, it only considers these 3 cells, right? But you could do it another way then, where it would also consider the cells on the other edge, the other side, right? And so in that case, the cells will kind of just keep going around. But that's kind of a design choice that we leave up to you. There's no right or wrong answer on that front. Certainly one's probably slightly easier to implement. So and then another, I think, architectural detail here. So if we're looking at the README, here it says uses double buffering to update the grid with the next generation. So what does that mean? Double buffering, and I think we talk about it a little bit when I was in one of these folders. Yeah, okay. So double buffering is a particular implementation kind of technique, and it's particularly prevalent in graphics programming. And this is the idea that perhaps on first glance, if you're just thinking about how you're going to be updating the grid of cells, maybe you're thinking, just iterate along this matrix on every generation, right? And maybe maybe that's possible, but that's actually going to be not as not as performant. So basically, what double buffering prescribes is you have memory set aside for two matrices, and when one matrix is displayed, we don't go and touch that one. Instead, the other one is where we will render the state for the next generation. So that'll get rendered out onto that other grid that is not visible in the current animation. And then when we animate, we basically swap them, right? So the grid that we just rendered on, that gets swapped, and then that's the one that's displayed. The one that was just displayed now gets swapped back, and that becomes the one that where we render the next generation after that, right? So it's like there's like one odd and one even grid in terms of like we're just swapping these back and forth. So some of the benefits are listed here. It makes the animation smoother, right? We just see the completed work for each generation. We don't want to kind of see the simulation being built as it's being built. We want the animations to be smooth in that sense. And it just makes calculating things easier. Yeah. He just had way more experience doing graphics programming throughout his career than I have. But I think for the most part, nice. So that's pretty much it in terms of logistics for the project. You're absolutely free to decide on implementation details, on what language you want to use, what frameworks you want to use. That is all up to you. I imagine most of you are going to be using JavaScript with React, which is totally fine. But if any of you are more adventurous and want to try doing it in some other way, that's totally open to you as well. But the idea is that eventually later on, this project is also going to be given to like iOS students or Android students or students from other tracks as well when they come in and join the CS cohort. And so they're not necessarily going to know how to use React to build this project. And so uh, we just basically give no constraints on how this will be implemented. That's really both not updating. I certainly have not, Gabriel. Oh, Gabe, for your particular issue, you might want to look into something called Node Version Manager, because it seems like you have, if you're having issues with upgrading, so it looked like you upgraded, but your version was still on an old version. Oh, you have it. Well, I'm sure there's instructions here somewhere. There's usage instructions right here. So maybe give that a try and see if that helps resolve your issue. Nice. All right. Any questions from anybody else? Is anything unclear about the project? Anything at all? Of course, if you figure stuff, if you encounter questions later, please reach out in the help channels. And yeah, if you're an MVP student, just basically consider yourself part of the main cohort now again. I don't know if we're going to move you guys back, but certainly you can go and utilize the same CS11 help channel so that students in the CS11 channel can also see those. And so we can get more cross-pollination that way. All right. As far as, so yeah, Tuesday and Wednesday, nice. Yeah, so tomorrow and Wednesday, there's going to be instructor hours then as well. I do have some things that I think are cool planned that I want to talk about. What's nice with the instructor hours during the project week is that it's kind of just at the discretion of the instructor about as to what they want to talk about. So I'm going to definitely take advantage of that. All right. Yeah. As Mark said, best of luck. Historically, when we used to run this project, so this project used to be one that was just part of the curriculum, like a number of cohorts ago. And students always seem to have a lot of fun with it, but I think we phased it out just because, well, I mean, implementing the simulation is cool, but probably not particularly applicable to anything. So that's why it was initially phased out. And then the project weeks rolled around and we were like, well, we need to give the students projects. Let's resurrect this one. So it's making a grand return. So I hope you guys have a lot of fun with it. All right. Thanks, guys. Good luck. And I will talk to you all later.